Hello everyone. Today, we will start getting acquainted with one of the most powerful tools for state management in Flutter applications, Bloc. I want to say in advance that this topic is complex, so don't worry if you don't understand everything the first time. But before that, let's review the solution to the problem from the last video. The task was to implement the ability to delete users from Firestore. To begin, we add a new method to our repository. It will be of type future, and its only parameter is the ID of the item we want to delete. The code is almost the same as in the edit method. We access our collection and then the document by its ID. Then, instead of calling the update method, we call the delete method, which allows us to remove the document from the collection by its ID. Having created the method, let's now add another icon in the trailing. As I mentioned in the last video, we can do this using row, but we must set main axis size to min. We add another icon button for deletion. In the onPressed method, instead of calling a dialog, we will simply call the method to delete from our repository. Not forgetting about await. That's all. Let's run the code and check if it works. As we can see, everything is working. Thus, we have implemented the ability to delete elements from Firestore in our application. Now, let's return to today's topic, which is state management using BI-lock. To start, let's define what state management means. Imagine you have an application like a calculator. When you press a button, the number on the screen changes. This number, in this example, is the state. It can change based on user actions or some program logic. We will use a special package called Flutter_Bloc to make this process more convenient and organized. When we have a simple application like a counter, we can update the state directly. We just increase the variable and display it on the screen. But what if you have a large application with many screens? For example, an online store or a social network. That's exactly the kind of situation where we use various state management patterns, one of which is block. Now, let's move on to the most important part. What is block? Block stands for Business Logic Component. Let's break down each word. Business logic. This is the logic that manages data in the application. For example, when we increment a counter, load data from a server, or handle button presses. Component. This means that all the logic related to data is gathered in one place. Block helps us separate logic, how the application processes data, and the interface, what the user sees. This makes the application easier to understand, scale, and test. Now that we've figured out what block is, let's look into what Flutter_Bloc is. This package is a special tool that simplifies the use of the block pattern in your Flutter applications. It makes the process of writing and maintaining code convenient and intuitive. Let's start by importing this package into a completely new project. Now, let's look at the main elements of block. The first is event. An event is an action that occurs in the application. For example, a user pressed a button. That is an event. Next is state. A state is what the user sees on the screen at any given moment. For example, the current value of the counter is the state. And lastly, what connects them is the block itself. A block is a component that receives events and, based on those events, changes the state. Let's imagine this as a dialog. The user sends an event and tells the application, "I pressed the button." The block listens and responds, "Okay, let's change the state." When the block updates the state, the application refreshes the screen, showing the new value from the state. Now, let's move on to a practical example. We will create a simple application where there will be a counter that increments when a button is pressed. First, we need to create an event an action that will occur in our application. I recommend doing this in new files, so let's create a new file for events. To begin, we should create an abstract class that will represent a general type for all possible events in the application. It will have no fields, only an abstract name. Next, we create another empty class, this time more specifically describing an event. For example, incrementing the counter by 1. This class will inherit from the abstract class and will also be empty. You might wonder why create several classes for one task, especially if they are empty. The reason is that by creating an abstract class, we gain the ability to add new events to our Bloc in the future simply by creating a new class and inheriting from the abstract class. Now that we have created the event, we need to define the state that will be held by our application. We will also create a new file for this. For our state, in this case, we won't create an abstract class. We will create a regular class that will represent the current state. This class will have one int field that represents the current count. The logic will be as follows. Every time the user presses the button, we will send an event to the Bloc. Inside the Bloc, we will change the state by adding one to this variable. Now, let's create the Bloc itself. We will also create a new file for it. The code here is a bit more complex, but I'm sure you will manage. To start, we declare a class and inherit from the Bloc class. Note that the Bloc class contains two generics for event and for state. You will understand later what these generics are for, but for now, let's declare them at the moment we inherit. For the event generic, we must pass the abstract class we created for our events. This means that by using this block, we will be able to use all classes that inherit from this abstract class as events. For now, we only have one such class, but we have the ability to scale our code by simply creating a new class that inherits from this abstract class. For the second generic, we pass our class for state. Now, we see an error. The thing is, the parent class does not have a no-argument constructor, and it must be initialized by passing a parameter of type state. This is needed to give our Bloc its initial state. Let's declare an empty constructor for our Bloc class, which we'll call the parent constructor and pass the required parameter initial state to it. As the initial state, we will pass an instance of our counter state, passing 0 as the counter. We covered this in our lessons on constructors. We could do this differently by passing the initial state of the parent class when creating our Bloc. However, the first method is usually preferred so that when creating our Bloc, we don't have to pass parameters related to our state. It's just an unwritten rule. Now, we need to complement our constructor by specifying curly braces and writing the code inside. This code, as we remember, will be executed when this block is created using this constructor. Our task is as follows. We have written events. We have also written a class for state. And now, in our Bloc, we need to specify that when a user sends a specific event, the variable from our state increases by 1. For this, the block has an on method. This method is used to register an event handler for a specific type of event. Note that this method also contains generics, and the type of the generic must inherit from the event we are using in our block. In this case, it is our abstract class. Thus, we can register an event handler only for classes that inherit from this type. Now, you will understand how this works. Let's register an event handler for our event, which should increment the value. We simply specify this type as a generic. Next, we need to pass the handler itself as a parameter. It represents a function with two parameters. The first parameter is the event being handled. In this case, it is our event for incrementing the counter. The second parameter is an object of type emitter. In simple terms, this object allows us to set the new state in our block. Now, we need to implement the logic for changing the state by incrementing the variable by 1. First, note that we have access in this class to the state field. This is the current state of our Bloc, and it is of the same type that we passed when declaring the class. Thus, this variable contains the variable that represents the counter. We need to somehow increase it by 1 and show Flutter that the state has changed. For this, we need the object of type emitter. This object has a method called call. This method takes a state, or more precisely, the updated state. We can do the following. Create a new instance of our state class and pass the current value of the counter from the state field. We will add 1 to this value. Another important point. If any class contains a method called call, we can invoke it without explicitly calling it. Just use the variable name of this class with parentheses. This is a feature of Dart. This will be equivalent to simply calling the call method. Thus, we have created a simple bloc with one event and its state with a variable of type int. When this event is triggered, the variable in the state will increase. Now, let's figure out how to connect this to our UI. We will do this from scratch, so let's clean up all unnecessary code, leaving only the main method. Now, let's create a widget for our screen. For now, it will be a stateless widget with a scaffold, containing an empty container in the center. We will also add a floating action button with an add icon. For now, we will leave onPressed empty. Next, in the main method, we will call the runApp method, passing it a material app, inside which our screen will be passed as the home parameter. Now, let's make it so that our counter is displayed in the center. For this, we need to get the state from our bloc somewhere and listen for its changes. For this, there is a widget called Bloc Builder. This widget also has 2 generics, but they are not the same as those in the Bloc class. As the first generic, we pass the type of our block, and as the second parameter, we pass the type of state that our bloc will have. Right now, you may find using so many generics confusing, but don't worry. With time and a little practice, it will become much clearer. Now, we need to pass the builder parameter. We must pass a function that returns a widget and has 2 parameters. The first parameter is the context. The second parameter is the state, which has the corresponding type. Inside this function, we have access to the state, which means we can access the variable responsible for the counter. Let's return a text widget with the value of this variable. Now, note where our block builder is located in the widget tree. It is a child of center. This means that every time the state changes, only that part of the widgets returned in the builder method will be redrawn. Accordingly, the scaffold, center, and our floating action button will not be redrawn when the state changes. Let's try running our code and see what happens. As we can see, we received an error. The issue is that we are using Bloc Builder, which tries to find an instance of our block in the context. But the problem is that we are not providing it anywhere. To provide an instance of the block, we need to use the Block Provider widget. I suggest wrapping our material app in a Block Provider widget so that we have access to the block throughout the application. This widget has a mandatory create parameter, which takes a function that returns some block. This function has one parameter, namely the context. In this function, we should simply return our block, which we will create using the regular constructor. As we remember, by doing this, we will call the parent constructor, initializing the initial state. In addition, the on method will be called, which will register the event handler. By the way, as we remember, we can simplify this anonymous function using syntax that replaces the word return. Let's try restarting the code once more. As we can see, this time everything is fine and we see the text in the center of the screen. However, we cannot increase the counter value because we haven't sent any events yet. To send an event to the block, for example, when pressing a button, we need to use the add method of our block. But we need to find a way to get an instance of our block in order to call its add method. For this, we need to use our context and its read method. This method is provided by the Flutter_Bloc library. This method also takes a generic and works as follows. When we pass it the generic of the block we need to retrieve, it starts looking for a block provider that is accessible to us in the context we provide. Since we are using block provider above our material app, we have access to it from any part of the application, which means from any context, including this one. Thus, by using this method, we will get an instance of our eLock. Next, we can call the add method, which allows us to dispatch an event to the block. In this case, we are interested in the event that should increment the counter by 1. We simply pass its instance. Thus, when it is added, it will be processed inside our block. This block will see that a new event with this type has arrived and will invoke the code inside the function we pass. In this case, it will update the state by incrementing the variable by 1. Once the state is changed, the block builder widget will redraw the widgets, taking the new state into account. This may seem like a confusing system at first glance. Let's run the code and check what we have achieved. As we can see, when we press the button, the value of our counter increases. Thus, we have implemented a very simple example of state management using Bloc. It may seem pointless to write so much code and so many classes for such a simple task, and you would be right. However, the point is that today we explored how this works through a simple example so that in future applications we can apply this in complex applications with large architectures. In the next lesson, we will continue to explore Bloc in more detail and add more events to our Bloc. If you have any questions, feel free to leave them in the comments, and don't forget to like and subscribe to the channel to not miss new videos. Thank you for watching, and see you in the next lesson.